It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plate thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people manage to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a megawave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first two waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of two tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot-high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along two tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half-inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels two-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moore tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-State tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long. July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, it lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore, Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or a big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, it had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling. The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored. Sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected.
Whoa, look at that view! It's a pity about the traffic. Yeah, we'll get a great view from inside the tunnel. What's going on? It's just a traffic jam. I don't know, but it doesn't sound good. Is that water? Yeah, it's probably rainwater. Although it is flowing pretty fast. There's water inside the car! I can't open mine. The water is too strong! Look! Do you see that? The end of the tunnel! We're almost out! The current will carry us out. We're gonna hit in! I'm trying! Help! What happened? Is that our car? That was too close.
Welcome to the virtual helicopter tour. We'll see the most picturesque sights of the city, although this place isn't real, and neither are its citizens.
Oh, wow! What a view! Whoa, it looks like a tsunami is coming!
Oh my cat, you're right. We should get out of here as fast as we can.
Please, tell me that this copter can handle a tsunami?
Don't worry, it's recommended to hide from tsunami waves at a height of at least 130 feet above sea level, and the record height that copters can reach is about 7 miles. Well, at least this city is just a simulation, and no one got hurt.
Hey, where did that fog come from?
It was formed when the wave hit the shore. By the way, the second wave may come soon, and the third one.
Then we should leave. But wait, can't we save those guys on the roof?
Of course. Hey guys, over here! Hurry up!
Seems like I'm safe here.
Nice to see you, honey. We didn't finish talking.
How did you get here?
You can't hide from me.
Challenge accepted. This roof looks good.
I'm gonna get you. Come on, come to mommy.
Leave me alone!
And speaking of that, you forgot about my mother's birthday, empty head.
See you never.
Show yourself. Where are my flowers? Where is my gift for Valentine's Day? Why are you so lame?
She got lost.
Peekaboo!
Oh well. What a wonderful day. Whoa! Did you see that? That was so epic! Wow! Alright, buddy. No time to think. Steal this car and let's try to survive.
Have you ever seen anything like this?
Not really. Look! The water's very close.
We need to get out of here. Now!
I'm doing my best.
Look out! Ah!
Hey!
Oh,
You okay? I didn't break a single bone.
we need to get to a safe space.
This is it!
Look out!
Hold on! We'll get out of here, I promise! Let's just try to run away from the waves. Hold on, I have a plan B. Oh no, plan B is canceled.
Whoa!
All right, let's give it a try. Not so fast.
Yeah. We need to get out of here.
I have an idea.
Here we go!
Come here. It's all over. Oh, we're so lucky.
Ava! Another wave!
No! Look out!
Ah! It's too strong!
Ah! Help me!
This can't be happening! Ava! No! She's not breathing. I'll need to give her CPR. It's 30 compressions in the center of her chest. Then 2 rescue breaths. Come on. I thought I'd lost you.
We can't go back out there.
We'll need to find another way out.
Come on, this way. Stay close.
We need to be careful. We need to get to higher ground.
Oh no, get out of the way!
I'm not giving up. We need to jump. Let's get out of here. Oh, what a serene morning. Whoa, good heavens. The meteors. Hold on. I need to move, and fast.
I don't like this, but hope this route will work. Stay calm, buddy. All right, what's the next step? Seems like it's my only way out. Let's take this path. It's about to collapse. The world's falling in on itself. I need to reach fire escape ladder. Hope the worst has passed.
Wow, that was a close call, thank heavens!
I got to move on. Thank goodness. Oh God, it's falling apart!
I'm okay, gotta move on.
What is that? A tsunami?
Wow, this is definitely my day.
A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600, before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with two more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteor tsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteor tsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. Earthquakes are a common thing in Japan. These natural disasters can reach a magnitude 9, where 1 is a light push and 9 can destroy entire cities. This happens because Japan is located on the Pacific Ring of Fire. It's like this. The entire surface of our planet is broken up into about 12 large pieces of the Earth's crust, and they're all moving slowly. In those places where these pieces meet, earthquakes occur most often. Japan is just at the point where the Pacific Plate collides with the plate of the Philippine Sea. This collision happens underwater and creates huge waves, and it could be much worse than just an earthquake. To escape from the water disaster, people built huge walls along the entire northeast coast. Not every earthquake provokes a tsunami. Many tremors occur when the Earth's crust diverges in different directions and creates gaps. It can destroy houses, streets, and forests, but such an underwater earthquake can't cause a tsunami. Huge waves are formed only when seismic activity causes the crust to move vertically up or down. The water pressure shifts at the very bottom, which generates a release of energy. This energy pushes the water and creates a tsunami. By the same principle, you can start little waves when you throw a stone into the water, and such vertical earthquakes often occur off the coast of Japan. First, a wave forms. It's gaining speed and increasing in size. Its height can reach about 40 feet, almost as tall as a 5-story building. It's approaching the coast and accelerating to 500 miles per hour. This is about the cruising speed of a commercial airliner. Millions of gallons of water weighing thousands of tons are getting closer. And now the wave is reaching the shore and demolishing everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. A tsunami that was that strong covered the northeast coast of Japan in 2011. It changed the landscape of the beach and the seabed. These changes are the reason for another dangerous natural phenomenon: underwater vortices. Whirlpools draw in everything that is nearby. They used to build dams along the coastline to protect coastal villages, but the wave force easily destroyed these walls. That's why, after the disaster of 2011, they decided to create new large-scale protection in Japan. They spent more than $10 billion in several years on it. As a result, they created about 440 massive walls all along the coast. They combined these sections into one large dam, almost 250 miles long and 45 feet high. The construction is supposed to protect the coast against strong tsunamis. But still, the government has moved some coastal villages to higher terrain. They also ban building anything by the shore. Despite the protection it gives them, many locals aren't happy with the wall. It's a huge problem for the fishing industry. The wall blocks access to the ocean, so ships and boats can't dock at the shore. Some people are unhappy that their windows now face the concrete wall instead of the blue ocean. The money spent on the wall could have been spent on moving even more houses. Residents have concerns the wall only creates an illusion of security. A giant wave can crash into it at great speed and break it into pieces. And these concrete parts can cause even more destruction. Some scientists agree with this opinion. Most experts aren't sure the wall won't give 100% protection, but it can help delay the flood, giving people more time to evacuate. In such situations, every minute counts. It's impossible to predict the earthquake occurrence accurately, but when it starts, the sensors can calculate how much time it would take for the wave to arrive at the shore. For example, the last time a tsunami warning was given 5 minutes after the earthquake. Any big wave is moving at great speed and may be very close to the shore. It seems people almost don't have time to save themselves from a tsunami. Fortunately, the citizens of Japan are ready for this. They regularly take part in tsunami evacuation drills. They learn how to act correctly during a coming flood. They have a plan of action that can save their lives. All that, along with a wall, increases the chances of surviving a catastrophe. Not only tsunamis are formed around the shores of Japan, the power of water here often meets the power of fire. In 2010, a few hundred miles south of Tokyo, near the island of Iwo Jima, a heavy low rumble came from the depth of the sea. Then 1 million bubbles moved to the surface. The water started heating up and boiling. Its temperature was so hot that you could poach eggs in it. The hot area grew to the size of a stadium. All this was accompanied by a huge amount of superheated steam filling all the air around. Then pieces of soil came out from the water. At this point, it was all over. The water cooled down, the ocean surface became calm again. On that day, an underwater volcano erupted. No catastrophe occurred, but in 2021, this happened again. Japan's Coast Guard warned of strong volcanic activity in the region. Hot steam and gases from the volcano's mouth burst out of the water and rose into the air to a height of 10 miles, which is about twice as high as the top of Mount Everest. A huge volcano woke up and began to rise slowly from the surface. If you look at this place from above, you can see that it's not just a volcano, it's a whole island shaped like a horseshoe. Seismologists say this volcanic island is just the tip of the iceberg, as they mix their metaphors. There is still a lot of volcanic space under the water. The island fills the air with gas and ash. The sky turns gray. Scientists continue to monitor the volcano, but they don't know what consequences this may lead to. Such eruptions of underwater volcanoes are not uncommon off the coast of Japan, but the event itself is unique. Underwater volcanoes don't explode and don't release lava flows upwards. A huge amount of water above them creates high pressure. As soon as the magma gets out, the water immediately presses it to the seabed. Millions of gallons of lava sink, cool down, and solidify around the volcano. This lava forms a thick layer of Earth's rock. Most underwater eruptions don't cause any changes on the ocean surface, but to make an island appear on the surface, a volcano needs a lot of magma. The next volcanic eruption creates another thick layer of it. Millions of years pass, and flows of lava form mountains. Constant eruptions increase the seabed height. Layer by layer, the cooled lava rises higher and higher, and then one day it appears on the surface and turns into an island. So, in 2013, a small piece of land appeared next to an existing island. Emerging from the water, the volcano began to grow slowly and eventually connected with the island. The area of this island increased by 12 times after 2 years. Vapor is always pouring out of this island, and its surface is filled with super hot lava flows. The volcano behaves unstable, and nobody knows when it's going to calm down. Once, people built a small town on a similar island. This place still exists today. It's located south of Tokyo and is called Aogashima. People are not too worried about the possibility of a catastrophe, despite the fact the last time a volcano erupted here was in May 1785. I wasn't around then. By that time, people had already built a city and lived there. Then, one sunny day, thousands of birds suddenly took off and left the island. Then the ground began to shake. A heavy, low sound came from the island depths. Streams of gas rushed from the top of the overgrown forest volcano. The volcano threw dirt and large stones into the sky. The eruption wasn't quick. It lasted several weeks. More than 200 years have passed since then, and the volcano is still sleeping. They rebuilt the city. Now this place looks like a dream. That's probably the reason why people don't want to leave it. Despite the risk of a new eruption, they continue to live and work here. There are many thermal springs. The island also has rich soil, and the waters around are full of fish. The volcano may wake up at any moment. Fortunately, meteorological and seismological services monitor the volcano activity. So, any guesses?